at home. Here we are, guys. Add and subtract those. Oh, do you know? Did you take the note? Okay, that's perfect. Since live. Add or subtract the following values in scientific notation. See what you guys can do with it, and away we go. Let's do this thing. Okay, can I get you guys back up here in 5, 4, 3, 2, 1. Before I clip this out, and just kind of keeping in our theme with our lesson last time, may I share with you guys what I think is the saddest thing about meat packing plants? I may? Okay, I will. So every slaughterhouse for cows specifically, because that's what we were talking about last time, actually has a resident cow. I don't know if you guys knew that. There's a cow who lives at the slaughterhouse. And the whole point of that cow is that cow just hangs out in the yard all day, and occasionally, well, they'll feed it all the time and give it water or whatever it wants, but they'll ring a bell and they'll blare a horn, and that tells the cow, oh, it's treat time. And so what the cow does is it goes over to where it knows where the treat is, which is up the ramp, goes up the ramp, and then over there, and then they just give it its favorite treats, and they pet it and tell it it's a good cow, and that they love it, and then they turn it around, and it goes back and hangs out in the yard. So here's why so how many of you are like, why do they have that? It's like, that's a weird thing to have. Here's why they have one. Because what happens is when they get a delivery of living cows, the thing comes in, drops off all the cows, and those cows have never been here before, and they're scared, and they don't know what's going on. But they let the cows hang out there for a little while, then they ring a bell, blare a horn, and one cow in this giant group is like, it's treat time! And he starts walking over here. And all the other cows are like, that guy looks like he knows where he's going. And they all start following him. And then they all start following those guys. And that cow goes over to the ramp, and all the cows are like, I guess we go up this ramp? And they all start going up the ramp. And that first cow is always this cow. And they pull him off the ramp, and they give him his favorite treats and wave at everybody else as they go by. Isn't it? Isn't that rough? That's a rough way to do it. Rough way to do it. But it works. It works. Alrighty. Can I get you guys back up here in 5, 4, 3, 2, 1? Like that cow gets calls from his parents, and they're like, how's life at the farm you're at? And he's like, well, it's not too bad. I make lots of friends, but they never stick around. All right. Let's see here, guys. I would love to get this. Jonathan, how would I subtract 4.5 times 10 to the 12th minus 3.7 times 10 to the 12th? Beautiful. Since the exponents already match, I'm going to do 4.5 minus 3.7. That's 0.8. And what am I going to do with the times 10 to the 12th? Yep, you just leave it alone. You just put it over there. I love it. That is exactly right. It's like, you just put it there? Absolutely. It doesn't change because we don't change the place value by adding or subtracting very much, usually. So let's go ahead and see what happens here, because the other question we have to ask ourselves is this in scientific notation, Eden? It is not. So I've got to get it in scientific notation. How can I get that number into scientific notation? Go ahead, Eden. Don't do the thing, Eden, where you're like beaming your thoughts to someone nearby and using their voice to answer. You know that freaks me out. Please use your own voice and tell me. So we've got to scooch the decimal to the left or to the right? To the right. How many places? Just one, because I want to make sure that 8 is in the ones place. Now that is going to change my exponent. What is it going to change my exponent to, Eden? What was that? 11. How many of us got 8 times 10? That was a janky looking one. How many of us got 8 times 10 to the 11th for that? Perfect. Yeah, that's correct. Because the original 12 wanted to drag this 8 12 spots this way, the decimal. And since we moved the decimal there, it's only got 11 spots to wind up at the same place. Very good. That's all there is to that. Let's see here. Let's get a little bit of help. And this one's going to come from Elin. How would you do number 2, 3.7 times 10 to the 15th plus 2.1 times 10 to the 14th? I'm glad we're talking. So you'll notice that when John did his, he just did 4.5 minus 3.7 and kept the exponent the same. Can you tell me why that method's not going to work on this one? There's different exponents. So we've got to change one of those exponents to match the other one. And the cool thing is, Elon, it doesn't even matter which one you do. It'll all work out in the long run. Do you want to move the decimal on the 3.7 or the 2.1? Okay, sounds good. He comes first. So let's do it. What do I need to change that 15 into? Well, let's, Elon, please. A 14. How will I change that 15 to a 14? By moving the decimal one space to the left or moving my decimal one space to the right? So let's talk about it. Let's talk about it. Right now it wants to go 15 spaces from here. How many spaces would it have to go from here to get to the same place, Elon? You'd have to move it to the right, but not 15 times. How many times? Oh, once and then 15 more, right? For a total of 16. And then from here, if I moved it right here, it would only have 14 spaces to go. So you were right to correct it. You were right to correct it. That makes it 37 times 10 to the 14th plus 2.1, that is not a 1, times 10 to the 14th. Sweet, I've got a match now, Elon. What should I do with those? Beautiful. Love to see that. Excellent. Times 10 to the 14th. Thank you, Elon. But is that in scientific notation, Dean? No. Nope. So what do I have to do? Oh, hold on. I'm not there yet. We're going to talk about that in a minute. I'm here. Elon's given me an answer that is mathematically correct. 39.1 times 10 to the 14th. But that's not in scientific notation. How do I get my answer to be in scientific notation? Mm-hmm. And that would be 3.91 times 10 to the what? The 13th or 15th? 15th is correct because it wants to go 14 this way, so it has to go 15 this way. I saw a bunch of hands shoot up. Did someone want to say something about that? I will say if you're careful and you're clever, you can actually notice that if you move the decimal on this one and put it here and change that to 3.7 times 10 to the 15th plus 0.21 times 10 to the 15th, if you notice, you can actually do this without having to adjust it at the end. How many of you have kind of noticed that? If you're careful with which one you pick, you don't have to adjust it at the end. That's cool. Guess which way I want you to do it. Do I want you to do it the way that Elon did it, or I want you to do it this other way? Whichever one you like. Whichever one you like. If you feel confident in like, oh, I like to, like maybe it's like a little challenge for yourself to try to adjust it in a way where you don't have to adjust it at the end, then I think that's cool. I love it. Let's see here, guys. Can I get a little help? Jack, how would you handle number 3? That's okay. Let's talk about it right now. Mm-hmm. Very good. And that is it 11? And so that would be 11 times what? Yeah, it doesn't change, just like John said. Just it is there. Very good. But is my answer in scientific notation? Let's see here. Garrett, is my answer in scientific notation? No. It sure isn't. So what am I going to do to adjust it so it is? Oh, well, how come? Like, that might be true. Aha, yes. And it wanted to go negative 23 from here, and now it's got one less space to go. So it would be 1.1 times 10 to the negative 23rd. How many of us were able to get 1.1 times 10 to the negative 23rd for that? Good, excellent. Okay, very good. Let's see. Let's see here. Was 22nd? Oh, 22nd. You're right. Whoopsies. You even said 22, and I just forgot. How many of us got 1.1 times 10 to the negative 22nd? There we go. That's better. I'm so sorry, guys. Do you guys ever do that where you're like, you know what to do, but you just write down the same thing that was there before just because, like, yeah, that happens to me all the time. Okay, thank you so much. Appreciate you guys keeping me honest. Let's see here, Truman. What is going to be my first step to subtracting these guys from number 4? Mm-hmm. How do we do that? Let's see. So that would be 94.5 times 10 to the... Well, that negative 8 wanted to drag it. Yes. I'm telling you, I always think about those little arrows, right? Like, I want to go in 8 spaces from here, and if I move it that way, he's got more spaces to go till he gets to where he wants to be. So we're actually going to have to shove it the other way. So 0.945 times 10 to the negative 7 minus 2.87 times 10 to the negative 7. Okay, Truman, what am I going to do with those numbers? Yeah, so, and I'm going to use my calculator. 0.945 minus 2.87 is negative 1.925 times 10 to the negative 7. And it's just that because they already matched. Is my answer in scientific notation already, Juliet, yes or no? It is, so you're done. The end. Great. Guys, this is kind of like your worst case scenario level 3 on your skill check on Wednesday. How many of us, by raise of hand, feel like if this is the worst level 3 that I could throw at you, that's not so bad? Yeah, most of your level 3s are going to be multiplication and division, but there will be one subtraction or addition problem on there, in addition to the level 4, which is going to be a little bit more than that. But we'll talk, okay? Let's see here, guys. It is the 62nd day of school. You know, the sum of the number of faces, edges, and vertices of both the dodecahedron and the icosahedron is 62. That is, if you take a 20-sided object and you take all the faces, which is duh, how many faces? 20, plus the number of edges, that's a little less obvious, plus the number of vertices, those are the corners, you get 62. But if you take a 12-faced object, a 12-faced regular dodecahedron, it's got 12 faces plus however many vertices it has, the corners, plus however many edges it has, and you'll also get 62. It's National Baklava Day. Yay! Where do you guys stand on baklava? Big thumbs up. Baklava is delicious and the best. Big thumbs down. I hate baklava. What's wrong with me? And then a shrug if you're like, what the heck is baklava? I've noticed there's lots of people who don't know what it is, which is so sad. Can someone explain what baklava is? Can someone explain what it is? Let's go for Ira.
It's like a dessert with a bunch of layers and some, I don't know what it is in the middle, and it just tastes really good.
So it's these crispy like pastry that like come in layers, and then you dunk it in honey and butter and nuts, and then you get it at the Greek festival, and you're sticky for the rest of your life, but it's worth it. How many of us now know what I'm talking about? Oh, you guys, the next time you're at a Greek restaurant with your family, get baklava. It's yummy. Some people disagree, and that's totally fine. I'd say the only thing that's not great about baklava is that you get really sticky after, and if someone hands you a napkin and you try to wipe your hands, now you have like napkin shreds all over your hands. It looks like your hands have been tarred and feathered. Yeah, it's like exactly how that works. You need wet wipes to eat a baklava, or you eat it with a knife and fork. But I just can't. I just have to get in there and like. Anyway, what's our first essential question? And I would love to get that from Miss Ella. Let's write that down. May we practice adding and subtracting values in scientific notation. While you guys are writing that down, classic NES games, before they were the face of Nintendo, and even before they were Super, these siblings were introduced to the world in this 1983 game bearing their name. That is indeed Mario Brothers. Mario Brothers. Mario was indeed in Donkey Kong. That was sort of where he shows up, but I don't believe that they actually gave him his name, and Luigi was nowhere nearby, I don't believe. Yeah. And so Pictionary Winter Olympic events is today. Hockey is what I'm looking for. Hockey, very good. So it's kind of a weird week for us. So what we're going to do, guys, is I want to make sure that you're feeling comfortable with where we're going. So today, guys, we're going to work on our self-assessment for adding and subtracting values in scientific notation. I'll be here to help you with that. Tomorrow, guys, there's going to be a review for your skill check, which is on Thursday. I will not be here tomorrow because I'm going to be at I'm going to be up at the University of Utah helping them write the secondary math 3 rise questions that you guys will have when you take secondary math 3 because they're not going to do Aspire anymore. I'm going to do my very best to make one of them funny. So if you see one on there that's funny, you'll know I succeeded. I will not be allowed to tell you if I was able to succeed or not. Yes, go ahead. No, I honestly, I cannot. I'll tell you right now. If I said yes, the answer would be no. Because the thing is that I can't. I've signed a non-disclosure agreement, and they could sue my pants off uh, if I go and tell people what I wrote on their things. Anyway, let's see here, guys. Just so that you get this information from me as a human being and not from me as a robot tomorrow when you watch the video for the review, I do want to go over our scientific notation scale. So our scientific notation scale, guys, is your level 1 is really, if you don't have to write it down if you don't want to, but your level 1 is I can identify if a value is or is not in scientific notation. Okay? You can identify if a value is or is not in scientific notation. For example, is this in scientific notation? Yes or no? No. How about now? Yeah, it's a different number, but that number would be in scientific notation. Is this in scientific notation? Yes, because that first digit's in the ones place, the 10 is a 10, and that thing is not a fraction. Is this in scientific notation? No, that number's got to be a 10, otherwise it doesn't work. We don't live in a base 9 system, no thank you. Okay, level 2 is I can convert, go ahead and no whistling, guys, extremely big / small values into and out of scientific notation. So I'll either give you something like 8.9 times 10 to the negative 8th, write that in standard form, or I'll say 42,000, like a number like this, and I'll ask you to write it in scientific notation. How many of us feel like you can manage that okay? You guys doing well? Yeah, those are your level 2s. Hello, Gretchen. What can I do for you? What? You can't have her! I'm just kidding. She'll leave in a minute. All right. So let's see here, guys. Level 3. I can multiply, divide, add, and or subtract values in scientific notation. How many of you feel like you can manage those? That's the bulk of the points there. Good, good, good. And your level 4, guys, your level 4 is that you're going to be given a story. And in that story, it will require the addition, subtraction, multiplication, and division. So maybe not all 4 operations, but more than one operation is going to be required of numbers that are both in scientific notation and out of it. And you're going to have to find a way to put those together to answer a question I have about it. Does that make sense? It's going to be a story. I'm going to give you a bunch of numbers. Some of them are going to be in scientific notation. Some of them aren't. And you're going to have to read that story and figure out what you're supposed to add together and when do we divide, what do we multiply by, all that good stuff. That's the idea. Will you guys open your planners to page 56? 56, please. 56. 56. Okay, page 56. for Monday, November 17th. Your self-assessment today is, okay, that was big, small, this is 9.4. Add and subtract in scientific notation. Okay? And then my first period was completely floored by this. So I don't know if you guys knew this, but if you turn to page 58 and 59, you can cross off Wednesday, Thursday, and Friday. There is no school on Wednesday, Thursday, or Friday of next week on page 58 and 59 for Thanksgiving break. So you guys are absolutely welcome to cross those off. I know a lot of people were surprised by that. Anyway, when I say teach, I want you to say, okay, let's go ahead and start working on our self-assessment 9.4, add and subtract values in scientific notation, see what you guys can do, and teach. And those of you at home, we'll see you later. Yes, Dewaney.